Okay, welcome to Chapter 3, the end of Chapter 3, which is solving systems of inequalities. And this chapter just involves a little bit of what we started with in Chapter 2 that Bill taught us with graphing these as individual, basically individual lines on a graph. And now we're going to do a system.
Right, and at the risk of telling you more than you want to know, these problems prepare you for something called linear programming that's usually covered in upper-level math classes, and these are actually used an awful lot in the real world. So a typical example of this is somebody has a diet where they have to get a certain amount of fats and calories and carbs, etc., and a nurse has to figure out how much of each different type of food should they be eating to make sure that they have not too many fats, but the right amount of calories, etc. And to do that, you do a problem involving what's called linear programming. And the first step in linear programming is solving systems of inequalities like we're going to go ahead and show you now. So these problems, contrary to the word problems we were talking about before, are used quite a bit in the real world.
Okay, well, let's go ahead and get started. This first one, x is less than 2. Now again, if you go back and you watched the lesson we did in Chapter 2 on this, you'll know that this is a dotted line. And this one's going to be a solid line, and that's basically because of the equal sign underneath. This is also a horizontal line, x equals 2, and this is a vertical line, x equals 2, and this is a horizontal line, y equals 3. So we go over here, and this is 1, this is 2, so x equals 2 is a dotted line. And the y equals 3 is a solid line. We apologize, we cannot use our credit cards on these machines to make them straight.
It's a lot harder to draw a straight line than you might think.
Now, unfortunately, this is the answer we get from a lot of the students, but remember, in order to solve these, you need to shade something. And obviously with a system, you're shading where the two shadings of each piece overlap.
Right, we're trying to find all of the points on the coordinate plane that make both inequalities true. So the question is, we essentially have 4 choices now where we can shade. We just have to figure out which is the right, I guess I'll call them corners. Which corners do we shade?
Okay, so on the first one, x is less than 2. I'll shade that one in red. Here's the line x equals 2. So all the values of x that are less than that are to the left. The second line, this one, was y is greater than or equal to 3. So I'll use blue on this, and all the y values that are greater than 3 are above. So the overlap is right in here. So we'll use a third color, green, and show you that this is where the overlap takes place, and that is your final solution.
And Jerry, I would say I do not see a future in art for you at this point, I don't think.
I never had one. All right, our next one. Okay, looking at this problem, you'll notice that this problem is a little bit more complex just because the equations are a little bit more complex. But you've had enough graphing at this point in the course to know how to take care of this. So I'm going to start with a simple XY chart to graph this first one. I notice that the first one's going to be a dotted line, the second one's going to be a solid.
Right. It's always a good idea to check that first because it's one of the most common mistakes. And you may find if you're working in ALEKS that everything in the problem seems right. You keep going over and over it. You can't figure out why it's wrong. And ultimately, the problem will be you have something that's dotted that should be solid or vice versa. So always check that first, whether it's a dotted line or a solid line.
Okay, since both of these equations are in slope-intercept form, we're just going to use the two values 0 and 1. Those are the easiest to substitute. Now, for those of you that can do this in your head, great. I encourage it. But for those of you that don't see it, I'm going to write it out. So when you plug in 0 into the first equation, you get 0 minus 2, which is negative 2. Then you substitute in a 1. 3 times 1 is 3. Take away 2 is 1. So you now have two ordered pairs, 2 points to plot. So 0, negative 2 is right here. 1, 1 is right here. And just remember to make that dotted line. And then you're going to test 0, 0. If you recall from Chapter 2, we said you want to test that point. As long as that point doesn't lie on the line, you can use it. So we're going to substitute 0, 0 into that first equation, and you get 0 is less than 3 times 0, take away 2. So is 0 less than -2? The answer is no, it is not less than -2. So we're just going to draw some single lines to remind us where the shading is going to take place. Don't want to overdo it at this point. I think in Alex, you have to wait until your final answer to shade. You just shade the final answer. So on your scratch paper, this is all you would do.
Right.
All right, the second one we'll do in blue. So we separate the two. And again, create a simple XY chart. Again, substitute in 0 for x. You notice this term disappears, so y is going to equal 1. Then plug in a 1 for x, so -2 times 1 is -2, plus 1 is -1. Okay, graph those 2 points, 0, 1, 1, -1. Now this is a solid line. Okay, now 0, 0 does lie just to the left of this, so I'm going to substitute 0, 0 in, and I get the following equation, which again, many of you can do this in your head. So is 0 greater than 1? The answer is no again.
No.
So that means you would shade the side opposite the 0, 0. So the final answer.
Right, the final answer is the place where you see essentially both colors. It's where you see both shadings.
That's it. So you'll start right about here or wherever, and we know, Alex, you don't have to do any of this. You just pick a region and click on the shade button, but that is your final solution to that problem. Okay. All right, this one, same principle. I want to pick up the pace a little bit. As far as, since these are in the slope-intercept form, that 0, 1 is the easiest method to use. So I plug in 0 into the first one, y is just 9. Plug in a 1 into the first one, y is 13. Coming over here, now you notice my graph paper, I was using these as 1s. I'm going to have to change it up now because I need a 13 here. 6, 8, 10, 12. Oh, it's going to be close.
Maybe count by 3s.
I think we'll count by 3s on this one. So 0, 9, this will be 3, 6, this will become my 9. And then 1, 13, right 1, there's 9, 12, this will be about right there. Obviously, Alex has that plot any point, and that makes that feature really nice, so it kind of adapts the coordinate plane to the point you give it.
Now, Jerry, we forgot to do something. Is this one a dotted line or a solid line?
Well, these are both solid.
Oh, okay, okay.
Both solid.
Sure that.
Okay, they both have those equal signs in them, so I'm going to draw the best solid line I can here.
That's very good.
And again, we will test 0, 0. So we have 0 is greater than 0 plus 9. So is 0 greater than 9, Bill?
No, 0 is not greater than 9. So,
no. So since here's your 0, 0, since it didn't work, you are going to shade the opposite side here. All right, second point we'll do, or second line, we'll graph in blue. Create a separate XY chart here. Start with a 0. -3 times 0 is 0, plus 4 is 4. Then we'll substitute in a 1. -3 times 1 is -3, plus 4 is 1. So graphing these 2 points, 0, 4, we just used it on the other line. Then 1, 1 is right here.
Jerry, that's not 0, 4 because we're counting by 3s.
That's right. Thank you, Bill.
That's okay.
We have to remember these things.
Yeah.
So we go back. 0, 4 is going to be about right here. And 1, 1 is going to be...
Yeah, have to guesstimate the best you can.
Yeah, it's about right here. So now drawing our solid line, we just know this is going to be a very
steep. Yeah,
very
it's a really steep
slope.
line. Yeah.
Now, looking at this, we still see our 0, 0, which is the origin, is just left of that line. So when I substitute 0, 0 back in, I get 0 is greater than 0 plus 4. And again, it doesn't work.
All right.
Zeros aren't working today.
Not at all.
So that means we would shade this way.
And again, now the region where you see both colors, that's the answer.
Okay, and that would be right in here.
That's that region right at the top of the graph seems to be the answer in this case.
That's it. Okay, so moving on, one more.
Right, we want to do one example where the equations were in standard form because we sometimes graph these in a slightly different way.
So when they're in standard form, Bill, I think, introduced this when he was doing these graphs earlier in Chapter 2. We like to use the intercept method, which is simply the 0, 0 method here. In other words, when you plug in 0 for x, that term disappears. So you're left with 2 times y equals 4. So we know y has to equal 2. Do the same thing. Now we're going to substitute 0 for y. So this term disappears. So you're left with x equals 4. So if you're at that point, that's great. About half of you are probably at that point where you can just look and graph, and that's where we want to be. Now, this is going to be a dotted line. We don't have the equal to sign. This one's a solid. So when I graph this one, 0, 2 is right here, and 4, 0, we're using the coordinate plane the way it's set up. These are all now 1s. All right, and then we're going to put our dotted line in here. And then we're going to test that point 0, 0 in the original equation. So we get 0 plus 2 times 0 is less than 4. So 0 is less than 4.
And finally, that's true.
It's true. So we do get to shade on the same side that 0, 0 lies on. Okay. Now the second one, we'll change colors. Again, the 0, 0 method. I believe Alex tries to encourage you to do 3 points on every one of these. Obviously, in the real world, when you're graphing a line, you just need 2.
That's right. Yeah, 2 points determine a line. You don't really need 3.
Yeah, and these are pretty short and sweet. So when you substitute 0 in for x, again, that term is gone, but be careful. You have negative y equals 6. So you basically have to move the negative over, making that a negative 6. Now, in the second piece, substituting in 0 for y, the y is gone. So then you're just going to divide both sides by 2, and you get x equals 3. So graphing these two, here's 0, negative 6 down here. And then 3, 0 is right here. Again, this is a solid line. And now testing the point 0, 0. So we have 0 minus 0 is greater than or equal to 6. Is 0 greater than 6, Bill?
No, it's not.
No, it's not. So that means we would shade the side opposite 0, 0, which is over here, thus leaving our solution as this large area down and to the right on that problem.
All right. Where do they look for this in the book, Jerry?
This is towards the end of chapter 3, and you'll find it, I believe, on pages 128 to 132.
Right, and these are difficult problems, but our advice is if you do these slowly, just try to do them step by step, draw the lines, figure out the shadings, and then see the place where there are both shadings, and then go ahead and shade that region last. I think you'll find that you probably can do these problems.
Absolutely.
All right, take care. We'll see you in the next Hot Topics.
In chapter 4.